Hi. All right. Hi. Thank you, everyone. Thanks, everyone, for attending this session. I know it's a little after the break, and it's a little late in the day. Everybody is waiting for the party. I did not put my slides in the PyTorch template, but I'm wearing the template, so it's all good. All right. So my name is Shailvi Wakhlu. I'm going to be talking about debiasing the data lifecycle. Data quality is a passion of mine, so very excited for everyone who's here. So what is bias in data? I know there's been a lot of chatter about it lately, and it comes down to two very simple things. Anytime you have data that is unrepresentative of the truth, or it is systematically skewed in some way, that leads to data bias. And the issue with that is that it leads to conclusions that are inaccurate, unfair, or misleading. And that is something that can cause a lot of downstream issues, which we want to prevent. So that's why this topic came up. So here's a meme that some of you might have seen, but it kind of illustrates how, like, it's one type of data bias. It's called the sampling bias, which is, the joke is, if I ask a bunch of people, hey, do you like responding to surveys? The only people who are going to respond to that survey are the ones who love responding to surveys. So you have a sampling issue of what is going on. There's a few other types of data bias. So there's the selection bias, which is if the way you were collecting the data, if that itself is over-indexing on certain demographics, for example, that leads to a selection bias. Sampling bias we just talked about in the last example. Response bias is something like, if I ask you, are you enjoying yourself right now? You may think the question is about my session, whereas some other people may think the question is about the conference in general. So how you respond is biased based on what you think the question actually is. Confirmation bias is something when I, as the person who's analyzing the results, already know what I want to see. So I sort of adjust the data to go to that. And the algorithmic bias is the final one, which is if you have a flaw in the design itself, so the way you've designed your algorithm, the way you've trained your data, that leads to algorithmic bias. So why do we need to address data bias? Great question. I could go into depth in all of these things, but this is a 10-minute presentation, so I'll keep it really short. Fairness, trust, and ethical and legal concerns are sort of the more external-facing reasons why it is important to address data bias. You want your product, whatever your product is, whatever you are selling to the market, you want it to be based on data that is fairly gathered. It is not disadvantageous to certain populations who may get a skewed product because of that. Trust in the market is super important. If you end up losing people's trust because they have seen that you have made biased decisions, that's a problem for your company. And ethics and legal stuff, there are some industries, I for example, worked in healthcare, which is, there are compliance requirements for how you have to think about and address data bias. But even if you don't, it is the ethical and moral thing to do to address data bias, especially when there are going to be big decisions made on it that affect large populations. The other three, like accuracy, enhanced decision, and innovation, those are more internal facing. Your consumers may never understand that you had a product that was inherently flawed because you used biased data to make a decision. You decided, should I go with option A or option B? And if the data itself was biased, if the methodology was biased, you made a worse decision. Maybe your consumers never find out, but that is ultimately worse for your company and for your decision making. It can hinder innovation because you're going after things that are not important. So ultimately, I say that harm is harm, regardless of intent. It is never a good excuse saying, I intended to do the right thing. If you didn't do the right thing, you didn't do the right thing. And you have to make a conscious effort to make sure that you are reducing harm in an intentional manner. So this brings me to sort of the three core principles of how you try to reduce data bias. So the first principle is make sure that your data, the data that you are using is aligned with the problem that you had at hand. Randomly picking up a data set somebody created 10 years ago to solve your problem today, when it wasn't even collected for that purpose, is usually not a good idea because you can have a lot of unintended consequences. And that is, it dovetails into the whole integrity in how you collect data. For example, like we talked about this earlier, that when you are collecting the data, if self-selection is going to be a problem, you have to be very conscious. Like, how do you remove the issue of self-selection when people are responding to something? How do you think about it? How do you tackle it? And the final piece is checking for personal bias. So this is, of course, hard because the whole point of a bias is that we don't usually know that we have it. We assume that that is the way. So this is where getting a diversity of perspective, doing retrospectives on what went wrong the last time, and pivoting based on that is a good step. So now to actually debias the data lifecycle itself. So data collection stage, this is where you are starting your entire data lifecycle at the collection stage. So how you diversify data sources, how you reduce the ambiguity that when you are wording a problem, when you have a form that's going to be ultimately used for your data set, how you word it and check for that ambiguity, like how will different people answer the same question, that is important at that data collection phase. Data pre-processing, so this again, a lot of time of data scientists is spent on this stage where you are going to be applying logic. This example, there's Legos. Someone has sorted it out by color, but maybe you were supposed to sort it out by size or shape or something else like that. So making sure that there is standardized processes when you are cleaning up the data, and that you are doing intentional audits that help you understand, like, did I do what I intended to do? And if you didn't get that result, what do you do next? Feature selection, so anyone who has worked with creating models is aware of this piece. I think this is something that's talked about very often, that you want to make sure that you are, when you add a feature, you want to make sure it is relevant to the data problem. If race and gender is not required, don't add it. There are many features that almost get people's flags up that there has to be a good reason why you're adding it in. If it doesn't, you may be just adding a discriminatory feature that inherently biases the model that's made on top of it. And then the algorithmic design itself. So when you are training data, this is again something that I think data scientists are taught very often, that, what was the training data that you used? And here I'd like to point out that there is no such thing as an unbiased training data set. Something that is unbiased in one situation may be completely biased in a different situation. So again, think of what it is, what you're using it for, and evaluate your algorithm itself. Is it really step A goes to step B, or is there some random other step in between that you have to think about to account for different use cases? The analysis and interpretation stage. So this is, again, something where you don't realize when there is bias creeping in. So the more you include a diverse set of voices in that discussion, the more you collaborate with cross-functional teams that get to weigh in. I, as an analyst, may see something, and then I talk to somebody in the customer solutions team, and they're like, nobody's going to look at it the same way. So it can be very eye-opening to just think about different perspectives. And of course, there are statistical methods that are specifically geared towards reducing bias in this piece. And then about the decision-making and application itself. So if you have a decision model, you have to do a regular audit to see if it is working as intended. Providing transparency is one way of sort of making sure that people understand what it was for and then try to evaluate whether it's doing what it said. But accountability is something that you have to prioritize it. That if you didn't do what it was intending to do, how do you sort of take accountability for that? And the last piece is ethical considerations. So all of the data lifecycle, you have choices to make at each of these pieces. If you have intentional guidelines, if you have philosophies that you all as a team agree on, it is more likely that you will have focus and you will notice when things are not going as intended. And here again, I say review and update practices intentionally, have a regular cadence at which you review those things and figure out what to do next. And so yeah, all of it kind of comes back to intentionality, that if you think that it'll just happen on its own, it's not going to. And that's it. I think my slot was only 10 minutes, so if anyone has questions, you can come grab me later. But I do have a 2-week data quality course. This QR code takes you to my website, which has more information about all of these things. Thank you all.